All right, so 3C.2, describing in behavior part 1. So we are talking about you should have blanks to fill in. So you're going to be filling in the blanks as we go through. Most of it is filled in for you because last year I learned trying to have students write all this down was crazy. So we're talking about in behavior of a graph. In behavior describes what the function is doing as x approaches positive infinity and negative infinity. And when we're referring to positive infinity, that means you're saying x goes to positive infinity. This is how we write it mathematically, okay? That just simply means go all the way to the right. So as you go forever to the right, what's happening? Does that make sense? That's what positive infinity means, all right? When we're saying negative infinity, it'll be written as x goes to negative infinity. And that's us asking what's happening as you go forever to the left of the function. Got it? So what is the function doing as you go forever to the left? All right. When we are looking at polynomials, we're looking at their degree. So your first blank is degree and leading coefficient to determine its end behavior. Okay. Together, those are part of what's called your leading term. So together, they're part of your leading term. Okay. Your leading term is when you're in standard order. It's going to be the very first term that you look at. Okay, so when we have a polynomial function, it would be written as p of x equals, and you have your a x to n term. Okay, that's your leading term. Because next you're going to have bx to n minus 1. And then you'll have cx to n minus 2. And it just keeps going. Okay, so that's what makes up a polynomial. So your leading term is the one that's in the front. Got it? All right. So in behavior, when you're looking at the end behavior, you're going to identify your leading term. In your leading term, you're going to look for your leading coefficient, okay? And you're checking to see, is your leading coefficient positive or is your leading coefficient negative? So is my leading coefficient positive or is it a negative number? Okay. Based on this, it means a thing. So if it's a positive, that means that the right side of your function, so we're looking at the right side, is going to be going up. So on the right side of my function, it's going to be going up. If it is negative, again, we're focused on the right side. That means the right side of your function is going down. I wrote that backwards. Don't look at that picture. You see nothing. Don't draw her. Don't draw her. That's not right. That was left. Your right side is going down. All right. The next thing we're going to look at in our leading term is our degree. Your degree, your highest degree, which means that it's your highest exponent. So the highest exponent on your variable, you're looking to see, is it even or odd? Okay. Is it even or odd is what you're looking at. If it is even, that means that your left side and your right side are doing the same behavior. So if my right side is going up, my left side is going up. If my right side is going down, then my left side is going down. They're going to be doing the same behaviors. Okay. If it's odd, then your left side and your right side are different behaviors. If my right side is going up, then my left side is going down. If my right side is going down, then my right side is going up. They're going to be doing opposite behaviors. All right. So because of these lovely behaviors, this is what leads us into our dance numbers. Yes. All right. So if you turn the page, we're going to look at our in behavior polynomials, aka our polynomial in behavior dance moves. All right. If you have an even degree and a positive leading coefficient, that means your right side is going up and so is your left side. So we like to call this raise the roof. We're raising the roof. If you have an even degree function and a negative leading function, that means your left side is going, I mean, your right side is going down. So your left side is also going down. And we call this shimming on down. Okay. If you have an odd degree and it's a positive leading coefficient, your right side is going up, but your left side is going to be going down. They have opposite behaviors. Okay. We call this staying alive. You'll see once we start dancing. Okay. If you have an odd degree and a negative leading coefficient, that means on the right side, you're going down, but on the left side, you're going up. So we are still alive. You thought you had me down, but we're still alive. All right. So I need everybody to stand up so we can do our dance moves. Today we are dancing. Last week we were singing. Today we're going to dance. All right. It is cool to dance in class. Okay. All right. So our first dance is for even positive. So if I have an even positive, we're raising the roof. We're raising the roof. Yep. Raise the roof. All right. Yep. Okay. If you have an even negative, you're shimming on down. Shimming on down. It helps you remember. Okay. If you are an odd positive, you are staying alive. Staying alive. Staying alive. You're an odd positive. Okay. If you are an odd negative, oh, you're still alive. Still alive. Still alive. Okay. And those are dance moves. We raise the roof. Whoop, whoop, whoop. We shimming on down. We stand alive. Stand alive. Still alive. Still alive. And those are the behaviors of your polynomial functions. Now, a bunch of things can happen in the middle, but when we're talking about end behavior, we're strictly looking at what is it doing on the ends. Does that make sense? All right. All right. Let's see if you got it. Let's see if you got it. All right. Let's look at example number 1. So example number 1, we have 4x minus 4 minus 2x cubed plus 6x minus 3. Okay. Are we in standard order? Are our powers decreasing? Yes. So that means that this is our leading term. Does that make sense? So looking at our leading term, we're going to pay attention to the leading coefficient and to the degree. So our leading coefficient, we're looking to see, is it what? Positive or negative? And our leading coefficient, what is it? Positive. Our leading coefficient is positive. It is a positive 4, which means that our right side is going to be going up. So here's Bob. Bob's hand is getting ready to dance. He's now going up. Okay. Next, we're going to look at in our leading term is our degree. Our degree, is it odd or even? Even. It's 4. It's even. Okay. Your degree, remember, is your highest exponent. Okay. And because it's even, that means that my left side is going to be doing the same behavior. So we're raising the roof. Ooh, ooh, ooh. Okay. All right. This is how we do our work to lead up to our answer. This is not your answer. Does that make sense? That is not your answer. Your answer is when you write it in a mathematical sentence describing what's happening to your end behavior. So the first sentence we're going to write is, what did we learn about our right side? So about our right side, as x goes to positive infinity, then p of x is doing what? What am I doing on the right side? I'm also going towards positive infinity. My y's are going towards positive infinity. Remember, p of x, anytime you're written in function notation, you're describing what are your y's doing. And my y's are going up. So they're going towards positive infinity. That is sentence number 1. Sentence number 2 is describing your left side. And remember, we talked about your left side is when your x is heading towards negative infinity. So as x heads towards negative infinity, then p of x, again, we're looking at our y's. What is our y's heading to? They're heading up. And if my y values are going up, that means they're heading towards positive infinity. This is the answer that you write. That is your answer to end behavior. Okay, this is your work. This is your answer. Make sense? Are you ready to try another one? Okay. Simple number 2. Are we in standard order? Our powers are decreasing. So therefore, this is our leading term. So looking at our leading term, is our leading coefficient positive or negative? It is a positive 3. Agreed? Because it is positive, that means that our right-hand side will be going up. So Bob is putting his right hand up. Okay. Next, we're going to look at our degree in our leading term. Our degree is it even or odd? It is odd because it is 7, which means that our left side is going to be going down. It's going to be opposite behavior. So Bob here is staying alive. Staying alive, staying alive. Okay, remember, this is our work, not our answer. Okay, when we're writing our answer, we're writing a sentence. As x goes forever to the right, what is your y value doing here? It's going towards positive infinity. As x goes forever to the left, what is your y value heading? Negative infinity. And we're going to write that as a sentence. So as x goes forever to the right, so positive infinity, then p of x is heading towards positive infinity. Do we see that? Okay. On the left side, as x goes to negative infinity, then p of x is heading towards negative infinity. And that is our answer for our end behavior. Are we catching on? All right. Let's do another one. We want to make sure that we're in standard form. So standard form means that we are in decreasing power order. Are we in decreasing power order? Yes. So this is my leading term. Looking at my leading term, what is my leading coefficient? Negative. It is a negative 2. Because it is negative, that means my right side is going to be doing what? Going down. Okay. Next, looking at our leading term, we're going to look for our degree of our polynomial. And our degree, is it even or odd? Odd, because our degree is 5. Because our degree is odd, we're going to be arms apart. We're going to be doing separate opposite behaviors. We're still alive, still alive. Still alive. So therefore, our answer is, as x goes to positive infinity, which means we're looking at the right, where is our y values heading? Our y values are heading to negative infinity. They're going down. That's sentence 1. Sentence 2, as x goes towards negative infinity, so which means we're looking at our left side, then p of x is heading towards where? What is Bob's left hand heading? It's going up, so it's heading towards positive infinity. And that's our second sentence. So that is our answer. Are you with me? All right. One more as a class. We're going to check. We're in polynomial standard form. So our leading term is this guy. Based on our leading term, our leading coefficient, is it positive or negative? Negative, because we have a negative 2. Because it is negative, that means my right side is going to be going down. Next, looking at our leading term, we're going to look at our degree. Positive. Our degree, is it odd or even? It's even because we have a positive 2 as our degree, which means that our left side is going to be doing the same thing. It's going to come down. So we're shimming on down, shimming on down. This is our work, not our answer. So our answer is describing as x goes to positive infinity, which is heading to the right, what is our hand doing on the right? We're going to negative infinity. And then we're going to go to the left. As x heads to negative infinity, then p of x, so what is my left hand doing? It's going down, is heading towards negative infinity. Neat, neat. And those are my answers. Pretend that I made a box around that, a pretty box. How you feel? Woohoo! Okay, so you have an exit ticket that you're going to do, and you're going to turn that in.